At the end of the last video, I told you that we will see one application of commutative property of whole numbers under multiplication. So let us begin. Say some students are attending a yoga class. They are told to stand in such a way that each row has 6 students and each column has 5 students. The arrangement is shown here. How many students are there in the figure? Will you count the number of students? There is no need to count. You can use multiplication to find the answer. The first row has 6 students and there are 5 rows. Therefore, total number of students is 6 times 5. It tells us that 6 is added repeatedly 5 times. It gives us the answer as 30. Okay, here's a question for you to answer. If we arrange the students like this, 5 students in a row and 6 students in a column, then will the number of students change or will they remain the same? The number of students will not change. In this case, the number of students is 5 times 6, which is equal to 30 again. The number 5 was added repeatedly 6 times. So this was about the commutative property of whole numbers. Addition and multiplication are commutative for whole numbers, while subtraction and division aren't. Let's move on to the third property of whole numbers. This one is called the associative property of whole numbers. Here again, we will first check for addition, that is whether whole numbers under addition are associative or not, followed by subtraction, multiplication and division. What do we mean by associative under addition? When we hear the word associate for the first time, the first thing that comes to our mind is to connect something, isn't it? It has a similar sort of a meaning here as well. Let's understand this with the help of a simple example. Consider addition of 3 whole numbers 1, 2 and 3. Now suppose I put a bracket around the first 2 numbers. How will you get the answer now? Well, we always consider the quantity which is present in the bracket and solve that first. Here we will first perform the addition of 1 and 2. The answer that we will get will be added to 3. 1 plus 2 is 3. Then we add this 3 with this one and that will give us 6. Okay, now let's put a bracket around the second and the third number. Before proceeding further, first let me just clear out a few things. We know that associate means to connect something. Here by putting the brackets around the numbers, we are connecting them. They are connected and hence that is the reason we will solve them first. Initially, we connected 1 and 2. Now we are connecting 2 and 3. Okay, let's solve this quickly now. 2 plus 3 is 5 and 1 plus 5 is 6. So we see that in both the cases, we get the same answer, 6. This is true for any combination of whole numbers that we can take. There are some examples shown below. Go through each of them. Whole numbers are also associative under multiplication. Consider this example where we are multiplying 3 numbers 4, 5 and 6. First we put a bracket around 4 and 5 and solve that first. 4 multiplied by 5 is 20. 20 multiplied by 6 is 120. Next, we put a bracket around 5 and 6. We will solve the expression in the bracket first. 5 times 6 is 30. 4 times 30 is 120. We see that in both the cases, we get the same answer. Here are a few more examples of this. You can also verify it yourself by taking any 3 random whole numbers of your choice. So whole numbers are associative under multiplication and they're associative under addition too. Now I want you to answer this multiplication. Do we really need to multiply these first 2 big numbers? Not at all. Now we know that this is the same as this. This one is easier because any number multiplied by 0 is 0. We get this term in the brackets as 0. Then we multiply 0 with 569, which is 0 again. This was actually an application of the associative property of whole numbers for multiplication. We didn't really have to waste time multiplying the first two numbers and then multiplying the result with 0. In the next video, we will see how we use the associative property of whole numbers to solve bigger multiplication problems.